Hi everyone. So welcome to Unacademy, India's largest learning platform. So you take the plus subscription and access unlimited live and recorded courses from India's best educator. Okay. So this is about me. I'm your computer science gate faculty, having more than 5 plus of teaching experience, mentored more than 15,000 students, taught in different coaching institute all over India, qualified gate multiple times. I've given gate coaching in many government colleges as well as in many private colleges like in SRM Chennai in Tamil Nadu. I went CET Bhubaneswar in Odisha, BC, Bhagalpur in Bihar, Jorhat Engineering College uh, in Assam, Dibrugarh University in Assam, Government Engineering College, Government College of Engineering Technology in Jammu, Ramgarh Engineering College in Jharkhand. So I went in different part of India and have given the GATE, CS and ITS parent for coaching. Okay, and even I went to Bangalore. In many parts of Bangalore, I have taken the coaching in Pune also. So you can download the Unacademy Learning app because there also I'm taking daily free live classes from 7 p.m. to 9 p.m. There I am solving previous year gate questions. Previous year gate questions of TOC. Okay, previous year gate questions of TOC we are doing. So you can unlock the free plans of Unacademy. So you can unlock the free plans of Unacademy using the code SPSYT. You can watch the free live classes. Yeah, good afternoon, Muskan. Quizzes, live test series, Unacademy Combat. Now, if you participate on Unacademy Combat, there is a reward. So, rank 1 is going to get a 3 month get an EAC plus subscription. Rank 2 and 3 is going to get a 1 month plus subscription. And rank 4 to 100 is going to get a 500 Amazon voucher each. 500 Amazon voucher each. Now, format. The question, one round of 15 questions is going to be, and duration is going to be 65 minutes. And syllabus is going to be whole syllabus of GATE, CS and IT. And it is going to happen on 26th of January 2021, 6 p.m. This is the link and invite code. You can use SPSYT. So you can follow me in Unacademy so that you will get the notification of all my free live classes. So today also, since it is having at 7 p.m., there we are solving previous year gate questions of TOC. So in plus you will get live classes, crash course, weekly test, doubt solving session, and both going to be in English and Hindi, and rank improvement batch. Okay, so in plus all the benefits is there, like live classes there, crash course is there. Yeah, good afternoon, Chetan. Weekly test is there, doubt solving session is there, rank improvement batch, and session is going to be both for separate. If you want to study in English, then study English, then Hindi, then Hindi. Okay, so in even Unacademy Gate Telugu has even started. Okay, so you can also see in YouTube Unacademy Telugu if you want to study the Gate in Telugu, then also it is there. So for iconic, if you want to study, means if you will take iconic subscription, you will get all the benefits of the plus. Along, you are going to get a personal coach, study planner, study booster session, personalized test analysis, and prepared study material. Also, you are going to get. So you will get top educator on an academy, and if you take Get an ESA subscription, you will have the access of all the courses. You will have the access of all the courses that comes in this domain. So not only CS and IT, you will have many courses like batch and year long courses in CS and IT, mechanical, and all the domains it is going to cover. Now, if you take an iconic subscription, the duration are of two kind. One is 12 month, one is 24 month. Use the code SPSYT, you will get 10% instant discount, and you can even redeem your credit. Again, you will get 10% off. So up to 10%. So up to 20% off you are going to get. And after 10%, this is the price 45225. And you can even redeem the credit. It will even get reduced. For 2 year, that this is the price 66,600. After 10% discount, again 10% you can get up to 10% by redeem your credit. Okay, now for plus subscription, you are having a 1 month duration, 3 month, 6 month. and even 12 month, 18 month, and 24 month. Okay, the six kind of duration. So this is the respective prices after 10% discount. Okay, the 10% discount, these are the respective prices. So for 1 year is going to be 27,225, and for 2 year it's going to be 39,600. Okay, fine. So in this class we are going to start type conversion. We are going to start type conversion. Type conversion. Okay. So today our operator and all these things is going to be finished. So right first, when an operator when an operator has, operator means plus minus. Okay, these are the operators. Has operands. Operands means like if you are having a plus b, then this is a operator. This is a operator. So I should write here a plus b. This is a operator, and a and b are operand. Okay. So when an operator has operands of different type, has operands of different type. It is having an operands of different type. Okay, of different types. So one is int, another is float. Then type conversion is going to happen. Okay, then type conversion is going to happen. So they are converted. They are converted to a common. They are converted to a common type. They are converted to a common type. Common type according according to a according to a small number of rules. There are some rules, according to that it will get converted. I will tell you the rules. If out of the, if one operand is this and another operand is this, then uh, in which type it will get converted. Okay, I will tell them. So there are automatic conversion is also there. Automatic conversion, that is called as wider and narrower. Okay, in general the only automatic conversion, the only automatic means it will automatically happen. Okay, the in general the only automatic only automatic conversions are those that convert a a narrower narrower operands into a wider to a wider into a wider one into a wider one without without losing information. Okay, so the automatic conversion, in general only automatic conversion are those that convert the narrower operand, will can convert into narrower operand into a wider one. With example, I will give you the example. Okay, will give you the example. Without losing information, such as such as converting converting an integer, to floating point, to floating floating point in an expression, in an expression. Example, like if you are having f is for float and I for is int. Okay, So this is the automatic conversion. So in general, only automatic conversion are those that convert narrower operand into a wider one. It will going to convert narrower operand into a wider one without losing the information, such as converting an integer. Will convert an integer to floating point. Integer to floating point. This is an integer. I is int. Okay, int, and this is a float. So before doing this operation, if you are doing, let us assume you are having a float f and int I, and if you're doing I plus f, so it will first convert this int into float, and then float plus float is going to happen. Then float. So I is going to get converted into float, and this is actually a float only. Okay, so this is float only. Then the resultant is going to, like, if you are having like five, if you are doing I equal to 5 and f equal to 6. So if you are doing I plus f, then 5 plus it's going to be 6 point something. So in general 360 you will get in your compiler. It will first convert into float. It will first convert like this. Okay, then it will be, so this way it is going to perform. Then resultant is going to, so this expression is going to a float type. Okay, going to be 11. It will convert narrower. So this is narrower is our int into wider one without losing the information. It has not lost any information, just converted into wider one. Just converted into, this is automatic conversion. Okay. Now there are some things which you are not allowed to do. So expression that does not make sense, like using a float. You are not allowed to use float in the array subscript. The array means when you are doing you're writing array 5, yeah, this is allowed, but inside that you can't write 5.5. Okay, this is not allowed. So these things is not allowed. The expression that does not make sense, like expressions that does not, that don't make sense, that don't make sense, like using a float, like using a float as a subs as a subscript. This is a subscript. Okay, using a float as a subscript are not allowed. Okay. Now next, it is important. Now wider to narrower to wider you have seen. Now expression that loss information, where you haven't lost any information, but here you will lose the information. So expressions that might loss information, loss information that might loss information, like that might loss information, like assigning, assigning a longer integer type, longer integer type to a sort, to a sorter, that in the previous lecture we have seen. Or a floating type, or it is important, these are the general things we see. Or a floating point, type to an integer, floating point type to an integer. So may, so sometimes it will draw a warning, or it is fine. See what I mean here. You have seen narrower to wider. Now wider to narrower, that is going to lose information. Like if you are writing int, if you are writing, if you are writing int I, if you are writing int I, and I is equal to your 5.5, then if you print I, then it will give the print I, then it will give 5. So that it is saying here. And if it is having a 2 byte, and if you will give more bigger number, like int I equal to 1 2 3 4 5 6 7 8 9, like this, you have given a very bigger number. Okay, then what it will do, it will convert into in their range, okay, this is allowed, okay, not illegal, this is allowed, but it will do it will happen, loss of information will happen, will happen, loss of information. Okay. So this is also automatic, is going to be compiler is this is going to be automatic. Okay, so it is saying that expression that does not sense, yeah, this one expression that might lose information, like assigning a longer integer type to a shorter. So you have taken a long number you have taken, and you are assigning into int, so it will lose some information. In int you are assigning a float, see, or floating point type to an integer, so it will lose the information. It will happen. Okay, so you have seen that a char is just a, and for char you have no. This is very very important. In the previous lecture, I also have given. So I've told you that a char is just a small integer. Never get confused between this. Char is not like a character. It's just a small integer. Okay, it's just a small integer. Char is just a small integer. So char can be. So I am going to show you one code. So that's why I am saying what is again char. So char may be freely used, may be freely used in arithmetic, arithmetic expression. So it is going to be freely used in arithmetic expression. So char is just a small integer. So char may be freely used in arithmetic expression. Now I will convert s to integer. Okay, I will convert s to integer. I will take some. So it will take some time. Let it be. Let it be. Okay. Now there is one more point for char. The language does not. The language the language does not specify the variable type char as a signed or unsigned. Means when you are doing char, so whether it is going to be signed char or unsigned char, the any that C programming language does not specify it. Okay, so it's vary from compiler to compiler. Okay, it's vary from compiler to compiler. So the language does not specify. The language does not specify whether variable whether variables of type whether variable of type char are signed or unsigned, whether it is going to be signed or unsigned quantities, that the language is not saying, that the language is not. Okay, so when you convert a char into an int, it can be even be negative. Okay, so because it is not saying that whether a char whether a variable of char is assigned or unsigned. Okay, that's vary from compiler to compiler. So when a char is converted when a char is converted to when a char is converted to an integer, when a char is converted to an int, it can. So the question is, can it ever produce a negative integer? So the question is, when a char is, you know that the char is saying that the type conversion is happening here. So when you are having a variable of char type, so the variable of char type can be signed or unsigned. It can be signed or unsigned. So the question is, it's very important. Okay, these questions they will ask in product based company. This is a popular because it is a difficult question. Product based company questions, like in Microsoft, in Amazon, these kind of questions they will ask. So when a char is converted to an int, when you are converting it char in interview, they can ask, when a char is converted to an int, can it ever produce a negative number? Is it going to produce a negative number? Now the question, if you are converting a char into an int, can it ever? So it depends upon the machine to machine. It depends to machine to machine. The answer varies. You will not able to say. Answer varies. Answer varies from machine to machine. Okay, some machine will give some output. Some will give positive. Some will get negative. Okay. So reflecting the architecture, reflecting the reflecting difference in architecture. What is the how is the architecture? Reflecting difference in architecture. Okay, understood. So on some machine, what happened? It convert when you convert in char to int, it will be positive. On some machine, it will be negative. So how it will happen? On some machine, on some machine, on some machine, a char whose leftmost. On some machine, this is second point. Point one. On some machine, a char whose leftmost bit is 1, whose leftmost bit is 1, will be converted into a negative integer. So when you convert a char into a integer, so on some machine, when the leftmost bit of char is 1, then it will be converted into a negative integer. So whose leftmost bit is 1 will be will be converted will be converted to a negative integer. So it is very important. It is very, very important, and this kind of questions they will ask in your product based company. This question is very important. So when a char is converted to an int, can it ever produce a negative integer? So the answer varies from machine to machine, reflecting difference in architecture. So on some machine, a char whose leftmost bit is 1 will be converted to a negative integer. On some machine, it will be, so that is called as sign conversion, sign extension. Okay, it is called a sign because one in the leftmost bit is used to indicate that is a negative number, and on some other machine, on other a char is promoted to an char is promoted on some machine, a char is promoted to an int by adding by adding 0 by adding 0 at the left end, by adding 0 at the left end, and thus is always positive, thus is always positive. So in some machine, what they do, they convert it into char. Okay, means they convert this char into int by adding a 0 on the leftmost end, by adding a 0 on the leftmost end. So promoted to an int by adding 0 at the leftmost end. Okay, so this is the case. So the only things the definition is guarantee, giving a guarantee. The definition of C guarantee that any characters in a machine, in machine's standard, printing character will never be negative. Okay, see the char, when you convert char into an int, it can be positive and negative. Okay, so on some machines it will be sign conversion, some machines will be like this. So the only guarantee that C is giving, that the definition of C is giving. So the definition of C, this is important. The definition of C guarantee guarantees guarantees that any character any character, it is important, that is any character in the machine's standard, that the any characters in the standard machine's standard the standard machine's standard character printing character set printing character set will never be negative, never be negative. So this character will always be positive in expression. So these characters will always, so this character will always be positive, positive quantities in expression. In expression is always going to be positive. Okay, so this is third point. And the fourth point is that the fourth point But if you take any arbitrary bit pattern stored in the character variable may appears to be negative on some machine, but arbitrary, if you take any arbitrary pattern, if you could take in any arbitrary, say only the printing, if you are printing characters will never be negative. The definition of C guarantees that any characters in the machine is standard. Printing character will never be negative. So these characters will always be positive in expression. So, but arbitrary, if you take any arbitrary combination, any arbitrary beat pattern, any arbitrary beat patterns stored in a character, any arbitrary beat patterns characters, stored in character variable may may appear, may appear to be, may appear to be negative, may appear to be negative on some machine, it will be negative. Okay, yet positive, on on others it will be. So what we use for portability is specify signed or unsigned character if a non-character data is to be stored in char value. Okay, fine, understood. So what you can do for portability is specify signed or unsigned. If non-character data is to be stored in a non-character data is to be stored in char value. Chetan is saying, please give. Yeah, I will give example. I will give now. Now only I am going to give the example. Okay, we'll give the example now. So like for like if you want to relational operation and logical operation are defined to have value 1 and 0, you have seen. See, now what we can do, let me give the example. Now how you can compare. Now if you want to compare, like D is equal to C if it is greater than equal to 0, and C is smaller than equal to. Now see, this is an assignment. D is having. See how we are comparing. I have told you that let's assume C is something you are taking. Okay, so you are checking whether C is a digit or not. You are checking whether C is a digit or not from 0 to 9. So when you learn these things, you know that this is an assignment operator. So the precedence of, I will tell you at the last the precedence table. This is a plus operation. Sorry, equal to. The assignment of that works from right to left. It will, so first this will get performed, then assignment will happen. It's a last precedence. Okay. Now since it is a and okay, so it is a logical and, so this will first happen left to right, it will be, then this, it will check. See, it is not a character, it's value, 0 characters value. If C is some value, it will check whether it is greater than equal to 0. It will take, see, 48 will be there because 0 character ASCII value is 48, and if you will add, then one character is going to 49, like this. So then for 2 is going to be 50, then 350, like this it will go increment. Okay, now similarly it will check till whether C is smaller than equal to 1, sorry, 9. So if I will give C equal to, if C will be any number, if C will be any number, like assume 5, then it will check whether is it greater, yeah, it's greater, and is smaller. So this condition will become true, this is true, then this is true, that is 1. So the output D is going to have is 1, the D is going to be have. Okay, if you want to compare the character, okay, so you use this way, so whether if your character they have given, whether they have given a digit or alphabet, like this you can. Okay, understood. Fine, is it clear, Chetan? Is it clear, Chetan, how D is going to be 1 if C is equal to 5? So this is the, this kind of questions is asked in your practical exam. Okay, now see, implicit conversion. So sometimes implicit conversion happen, and then implicit conversion. Now we are going to see implicit conversion. One is so we have seen the type conversion. Now we are having a two types of conversion. One is implicit, other is explicit. Implicit means that is done by automatically, means the compiler is doing implicit conversion. Okay, implicit conversion. Now we are going to see implicit conversion, then explicit we are going to see by type name. Okay, by type operator that we will see. Implicit conversion work much as expected. In general, see, in general, if an if an operator if an operator if an operators like like plus that you have seen, that like plus or star, that takes two operand, that takes two operands two operands as operands of as operands of different type, has operands of different type. If it is having an operands of different types, then what will happen? The lower type will be converted. The lower type is promoted. The lower type is promoted to the higher type. The lower type is to be promoted to higher type, before the before the operation operation proceeds. Before the operation, this is implicit. Automatically it will happen. So if you are having a binary operator, if you are having in both side, if you are having two different operands, okay, that takes operands and operands of different type, then lower type is promoted to higher, then lower type is going to be promoted to higher type before the operation proceeds. Okay, before the operation. Now the result, what is going to be the result type? The result is of higher type. The result is of the result is going to be of higher type. The result type is going to be of higher. Okay. Now I will give you the all the rules that by seeing the operand how this conversion is going to happen. Okay. Now all the rules I am going to. Now third point. So this is important. This is the rule. If if there are if there are no unsigned, if there are no unsigned operands, if there are no unsigned operands, however, means if there are no unsigned. Okay, I am asking about if the operands are signed, then only these rules will open. If there are no unsigned operands, so these rules are very important. The following, however, the following, the following information, the following informal set of rules, set of rules will be enough. Will be enough. Okay. So if you are having means it, what I mean that if you are having here one unsigned one unsigned operand and another is also having unsigned, then this rule will happen. Not signed and unsigned. For unsigned, this rule is going to be happen. Okay. So if there are no unsigned operand, the following information set of rules be. The first one is if either operand is of long. So this is the rule one. If operand operand is long double. If either operand is long double, then convert the other operands. The then convert the other convert the other to long double. Then you have to convert the other to long double. Otherwise, first you will check if it is having a long double, then convert to long double. If it is not long double, then otherwise, if either operand is double, if either operand is double, if either operand is double, convert the other to double. Convert the other to double. So we will convert the others to double. So if either operand is double, then convert other to double. Now otherwise, if it is not long double, if it is not double, then if either operand is float, otherwise you will check. Otherwise, if if either operand, in this way only you will check. First you will see long double. If it is long double, then convert everything into long double. If it is double, after, if it is not, then otherwise. If the operand is double, then convert the other to double. Otherwise, either operand is if either operand is float is float, convert convert the other to float. Then you have to convert the other to. Otherwise, what you will do? Otherwise, convert convert. So if it is not float, then it will be either char, and if otherwise, convert char and sort to. So if it is having either char or sort, convert it into int. Convert it into int. Then then if either then if either operand is long, then if either operand is long, either operand is long, convert. So this is the if cases. Then after if, then if either operand is long, convert convert the other to convert the other. Now I will take an example. With example, I will make it clear. So if you are having one long double, if you are having one long double, D LD, okay, LD, and if you are having one double, that is DD, and if you are doing LDD plus DD. So if either operand, first we will see if either operand is long double, yes, it is having long double, then it will convert this double into long double, will convert into long double, then it will do the operation, and so it will be long double. That I mean. So and if LZ double this, then float F, then if I'll do DD plus F, then it will convert this F into, it will convert it into double, then it will start. Because the third saying otherwise, second point is saying otherwise, if the either operand is double, if the either operand is double, then convert the other to double. So what we are doing here, we are generally converting the lower type is promoted to higher type. Okay, we are converting. This is the implicit conversion where lower type is going to promote it into higher. Okay. Now this you have seen in case of unsigned. Now if it will be signed, then signed. In case of now signed character, signed operand. Now if it is signed operand, then it is a machine dependent. Is a machine dependent. Let me write. Let me write. Conversion rule are more complicated. In case of in case of unsigned. Sorry, case of unsigned. In this we have talked about signed. Okay. So this we have talked about signed. However, if the operand are no unsigned, if no unsigned, now if it is having a signed, okay, it was having not unsigned. Now if it is having an unsigned, now if it is having an unsigned, okay, unsigned. So like where you are not having negative, okay, now you are not going to have a negative number. So conversion rules are very complicated when unsigned operands are involved. The problem is that comparison between signed and unsigned values are machine dependent. What is that? The problem is that the problem is that that comparison between signed and unsigned signed and unsigned values, signed and unsigned values are 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 machine because why? Because they because they depends on the size, because they depends on the size of the various integer. That depends upon the size of various integer. It depends on the type of various integer. Okay. So in case of unsigned operand, the conversion are machine dependent. Okay. The problem is that comparison between signed and unsigned values are machine dependent. It is going to be a machine dependent because they depends on the size of various integer type. So it's going to depend on the size of various integer type. Okay, fine. Now I will take an example. With example, I will make it clear. Now take an example. For example, suppose 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 int is 16 bit. Suppose int is 16 bits and long is 32 bit. Then if I write minus 1 l, it is a long and 1 u, 1 u. Then which is greater? It is unsigned int. It is u means unsigned int. So see what I am saying here. You have taken that int is 16 and long is 32. So it is saying that the problem is that comparison between signed and unsigned values are machine dependent. It is going to be machine dependent because they depends on the size of various integer. So if I am writing minus 1l to u means it is long and it is unsigned. So before doing the operation, before applying any operation, it will convert into unsigned long because the higher operand is this. You know that lower operand is always get converted into higher. See, always lower type is promoted to higher type before the operation proceed. So now both is having unsigned long. Both is having now see this is unsigned long and this is long only and this is long only. Okay. So sorry, 1 minute. This is signed. This is not unsigned. This is going to be your, because minus which is int is promoted to signed long. It is going to promote it into signed long. So which is going to be greater? If in between these two, which is going to be greater? This is going to be. Why? Because it is having signed long, so it will get converted into signed long. Okay, it will get converted into signed long because right because one u which is int which is int is promoted to a signed law, because here it is a signed law, so it will get converted into signed. Now next example is very good. With next example it will be more clear. Now if I write like long minus 1 long and 1 unsigned long. Now between these two which one is greater? Now tell me, between these two which one is greater? If I'll apply the operator, which is going to be greater? Which is going to be greater? Now this minus 1 log will get converted into, see, long and this unsigned long, which is having higher, which is higher type unsigned long. So this signed long will get converted into unsigned long. Will get converted into unsigned long. So it is going to be greater. It is going to be, why? Because minus L is promoted. That's why in case of unsigned, we it is a machine dependent. Okay, promoted to, see, it is difficult to understand. If you are having doubt, you please ask me, because minus 1l is unsigned promoted to unsigned law, and thus when it's converted to unsigned law, just like if I'll ask you Say with simple example, I can make you understand. So if you are having, it will get the size of long is going to be very big number. The size of long is going to be very big number, like it is going to have uh, 7, means it is going to be very big number, so minus will not be there. It will go round up. See, what I want to explain you, that let's with integer it will be more easy to, if I'm saying that size of int is something, and in unsigned I'm using unsigned int. Here I assume that unsigned is 16 bit, unsigned I assume as a 16 bit. Then unsigned int I is equal to -1. If I write it as a -1, then since it is unsigned, it is not going to take -1. It will take the positive value, and which positive value it will go round. So it's going to be 0 to 65535 is something like this is the range. So it will take this one. So if you print I, it will take the last value. It will take the last value of that. Okay, it will take the last. Are you getting? Print I, then it will take the last value. Let's assume the last, the range of, let's assume, I don't know the exact number. Let's assume the last number is this. So it will print this 65535. 65535. Okay, 65535 it is. Am I clear? So because it will become, it is not now not going to be minus, it is not going to be long, it is going to be unsigned long. Because -1 is promoted to unsigned long, and thus appears to be a positive, large positive, thus appears to be large, understood? Now, see. Now, next type of conversion, if you are doing assignment, then how the conversion will happen? So, conversion take place, across, conversion take place across assignment, cross assignment, cross assignment. It also going to be take place. The values of the right conversion take place across assignment. Also, the conversion is going to take place. Okay, the value of the right side, value of the right side is converted to the type of the left. Is converted to the type of the type the left is going to be converted to the type of the left, which is the type of the result, is the type is the type of going to be the type of. So conversion take place across assignment also. It is going, the value of the right side is converted into the type of the left. Whatever the value it is having in the right side, it will get converted into type of the left, which is going to be the type of the result. Means with example. Okay, with example I will explain you what I am saying. If you are having int I, if you are having int I, and if you are having a char c, you are having a char c. Now I is equal to c, I is equal to c. Now what will happen, this char will get converted into int. Char is going to convert it into int. Okay, this char is going to be converted into int. So that I'm saying here, I'm saying here the value of the right side is converted to the type of the left. So here type of the left is going to your int. So c is going to be converted here. C is going to be converted into. Okay, understood. So in this way, if you have written, your first converting cat to int, this value is converted into int. Now again in C, so char is converted is into int. This you have done. Now in C you are writing I. In C you are writing I. So whatever it was having, it is having now. Okay, now int you have converted into C. So no change will happen. The value of C will remain same. The value of C will remain, okay. Understood? The value of C is going to remain same. It's not going to be changed. So here the value of C, here the value of C is unchanged. Unchanged. Why? Because we converted this to int, and this int I am giving to char. Because same thing, this C is having one I, so then again I am giving. Okay, understood? So understood now. Now see, float to int, and that you have seen. Let it be. Now we will see explicit conversion. Now we will see explicit conversion. Implicit we have seen. Now we will see explicit conversion. We are going to see now explicit conversion. Explicit conversion. So explicit conversion happen by using type diff. It is now we forcefully want to convert into another type. It is done by using this type. This is unary operator. This is unary cast. It is called as by using. Let me write with a. This is done by using unary operator called cast. Name is cast. By using unary operator. By using unary operator called a. Okay. It is called as a cast. So syntax is like, here you will write type name, and here you will write the. So it will convert whatever type you are writing, it will convert that. This is the syntax. Okay. So generally you have used this syntax in whenever you are doing dynamic memory allocation, when you are calling malloc. Okay. Then a into size of int, like this you are. I will teach you this also. I will teach you size of int you are doing. Then it is malloc return void star. Now you want to convert it into int. So type conversion you want explicit. This is the explicit type conversion, like int star you have done. Okay, this is the example. And in functions also we do the type conversion. That also I will tell you. Okay. The next point you write, since an argument, since an argument, since an argument of a function, since an argument of a function call is an expression. It is going to be expression also. I have told you the definition of expression. So argument of a function call is an expression. It is an expression. It is an expression. So you can even do the typecasting of that. So typecasting also take place when argument are passed to a function. So conversion, type conversions also take place. So type conversion also take place when when argument when arguments when arguments are passed to function. So when argument you are passing to a function, type conversion will also happen. So in the absence of function prototype, if you have not given a function prototype, in the absence of, it is important, in the absence of in the absence of a function in the absence of a function prototype in the absence of a function prototype, the char and sort become int. Char and sort is going to become int. Char and sort become int, and float become double. Float becomes floats becomes double. Float is going to become, okay. That's why we have declared function argument to be int and double, even when the function is called with char and float. Because see, if you are having, see, if you're not given a function prototype, if you're not given a function prototype, and char and sort will become int and float will become double. What I mean here means, if you are if you are writing some function, and that prototype you have not given, you have given some function, function is equal to your int I, you have given, and some work is doing, I is equal to I into 2, like this you are doing. Okay, and you are doing something. Now if you are calling this function on 2, see, this 2 is going to convert it into int. Why? Because it is in the definition. If you'll see, it is in the range of sort and char. It is sort, it is also in the range of sort, because sort is a small value of small data type of int. So this will get converted into int. This 2 will get converted into that. It is saying, see, in the absence of a function prototype, char and sort become int. Like if you, here you can call as fun a. So that is going to be converted. This is this is a character data type, but it will get converted into int. Okay. So similarly, if you are having fun2, and if it is having a, it is taking like, if it is taking like double, double, it's taking a double. Okay, double d, some work is doing. And if you're calling this function 2 by giving some number, like let's assume it is having some int f, so not float. If it is having a float, so it will convert float into double. Will convert float into double. Here also conversion is going. If you're having a float f, and if you're calling, let's assume f is having some value, f is equal to 5.6 point something is there, and if you're passing this value, then it will get converted into double. F will get converted into double. Okay, see, float will become double. So char and sort become int. In the absence of function prototype, char and sort become int, and float become, understood? Now see, this you have seen the explicit int star, you are by using this type casting you are doing, explicit conversion you are doing. Now, the precise meaning of a cast is of is as if the expression were assigned to a variable of a specific type, which is then used in place of whole construction. Okay, so with example I will explain. Now, right, this point is very important. The precise, if you want the precise meaning of, the precise meaning, the precise meaning of a cast is as if the expression, as if the expression, as if the expression were assigned, the expression were assigned to a variable of the specified, the specified type, which is which is then which is then used in place, of the whole, construction. So the precise meaning of a cast is as if the expression were, assigned to a variable. So is as if the expression, if that expression is assigned to a variable of a specified type, which is then used in place of the whole construction. Okay. So with example it will be more clear. Like if you will see this square, that library function is square, that is going to is square root. If you will use this library function is square root. Okay. So a square root takes a takes a number. It's function prototype. Its function prototype is its function prototype is return type is double and square root, and it is taking double. It's a function prototype. Okay. So whenever you are calling this function on some number, like if you are calling this root, you are calling some root 2 on square root 2, it will convert this 2 into double. It will convert the 2 into double. Okay, it will convert this 2 to double because its prototype inside the function, that is dot h, is written as, the declaration is that double. Okay, is it clear? So whenever you are calling square root on double, on integer, it will convert this square root by using double. This is the type casting is going to happen, and here it will have n. N is integer. N is an integer. This I am trying to tell you. So if you are having this is the square root function which is used to do square root of n. Okay. So if you are calling this function, if you are calling this function on int, it will convert into its, it will do the type conversion. It will convert this int to double. It will convert into double. So we have to convert this into double. Okay. Understood? So whenever I am converting this, whenever I am converting, like you have written, like you have converted before calling this, if n is an integer, if n is an integer, if n is an integer. Now if you are before calling, you are converting this, like if you are calling square root, okay, on double, you are here, you are writing double, and here you are writing n. You are calling this, okay, square root, you are calling this function and you are converting this into double. It does not mean that you are converting int, sorry, it does not mean that n is going to be converted. It means that expression is going to be now passed as a double. Okay, so the cast, this is very important, don't get confused. The cast produces the value of n in the proper time. N itself is not changed. N is not going to change. Okay, n is not going to be changed. It is going to be converted. This expression is going to be converted. Okay, okay, Madhura, I am explaining. See, the cast, let me write the cast. The cast produces, let me write that the cast produces the value of, the cast produces the value of n in the proper time. In the proper time, let me write, then I will explain. The proper time. N itself is not altered. Is not going to alter. Okay. The cast operator has the highest, that I will teach you. See, what I am saying, that the prototype of square root is double. It will return double value. It is square root and it is going to take some value which is double. It will take the argument as double. It is the prototype or function declaration of function declaration or function declaration. Okay. Now, whenever you will call this square root, and if you are giving some integer, then you have to do typecasting. So you are writing the as a type. You are doing typecasting of this expression into double. So the cast produces the value of n in a proper time. Means it will pass the value of n as a double. Means it will pass the value 2 as 2.0, as 2.0, some double. But it will not convert to. It will not convert to, and n itself is not altered. Okay, so if you print n, if you print n, then whatever n was having, it will be as it is. Whatever n was having, it will as it is. It is not like n point 0. Understood? That I am trying to say. So cast is going to, where it is passing the value, that expression is going to get of that cast. Okay, that time. But it's not going to be, that expression is not going to change. What I mean, that if you are having like int float, okay, like malloc function, where we properly use int star, we do malloc, and we are doing something, we are writing. So it is saying that whatever address you are doing, they are casting that, but whatever value it is having, that is not, this is not going to change. The value that is going to be passed, that is going to be changed. Are you getting that? Like if you are passing if double, if double and n, so n is not going to be changed. When you are passing here, it will store as a double. क्लियर हो रहा है क्या? पास करना, जैसे इसको डबल में पास करना है तो डबल होके पास होगा. एन अगर 5 रहेगा तो 5.0 होके चला जाएगा, लेकिन एन 5 का 5 ही रहेगा. एन एन चेंज नहीं होगा. समझ में आया क्या? मधुरा, क्लियर है क्या? टाइप कन्वर्शन क्लियर हुआ? टाइप कन्वर्शन क्लियर है सभी को? सो हमने टाइप कन्वर्शन में क्या क्या देखे, समरी एक बार बता देते हैं। हमने देखे कि टाइप कन्वर्शन हम कर सकते हैं, इम्प्लिसिट देखे, एक्सप्लिसिट देखे। ठीक है, एक एक रिकैप दे देते हैं। तो टाइप कन्वर्शन में देखे, जो पहले देखे कि अपने आप जो हो जाता है। ठीक है, सो हमने क्या क्या देखे, जब डिफरेंट टाइप का ऑपरेटर है तो टाइप कन्वर्शन होता है। नैरोअर टू वाइडर अपने आप हुआ, इनटू फ्लोट हो गया। ठीक है, फिर इसमें हम फ्लोट नहीं लिख सकते, ये देखे हमने। फिर जब हम लोग लोअर से देखिए, दैट लाइक असाइनिंग लॉन्गर इंटीजर टू शॉर्टर में करेंगे तो एक्सप्रेशन कुछ लॉस हो सकता है, देखिए हमने ये। फिर एक रूल है जो सबसे ज्यादा इंपॉर्टेंट है। फिर कैर का देखिए, ये जो सबसे इंपॉर्टेंट है कि कैर को जब भी हम इंट में कन्वर्ट करते हैं तो वो नेगेटिव पॉजिटिव क्या होगा, मशीन डिपेंडेंट। ठीक है, वो हमने बताया आपको, बहुत इंपॉर्टेंट है। फिर हमने ये रूल्स देखा, इम्प्लिसिट कन्वर्शन का, लोअर टू हायर कैसे कन्वर्ट होगा। तो रूल किस में कन्वर्ट होता है, जो ये कन्वर्ट होता है रिजल्ट, वो हायर टाइप में कन्वर्ट होता है। हायर टाइप में तो अगर कोई भी ऑपरेंड हो गया, अगर आपका लॉन्ग डबल है तो वो सारे को लॉन्ग डबल में कर देगा, अगर डबल है तो सभी को डबल कर देगा। तो वो सब हमने रूल्स देखे। फिर हम लोग अनसाइंड देखे। फिर हमने देखे यहाँ पे अनसाइंड में हमें कोई रूल नहीं है, ये मशीन डिपेंडेंट है। साइंड में सिर्फ रूल है, अनसाइंड में कोई रूल नहीं है। अनसाइंड में कोई रूल नहीं है, मशीन डिपेंडेंट। फिर एक्सप्लिसिट कन्वर्शन देखे बाय यूजिंग टाइप, जो यूनरी ऑपरेटर जिसको हम कास्ट करते हैं, यूनरी ऑपरेटर। ठीक है, अब हम लोग देखेंगे इंक्रीमेंट एंड डिक्रीमेंट ऑपरेटर। इंक्रीमेंट एंड डिक्रीमेंट ऑपरेटर, तो टाइप कन्वर्शन हमारा हो गया। अब हम लोग देखेंगे इंक्रीमेंट एंड डिक्रीमेंट ऑपरेटर। Increment and decrement. Now we are going to see increment and decrement. Okay, increment and decrement. Increment operators जो हमारा है, increment operators is like plus plus and decrement operator is minus minus. Increment operator का नाम क्या है? It is plus plus our increment operator. Minus minus is the decrement operator. So the increment operator. So what is the work of increment operator? It's increment the operand by one. By one. Operator Increment operator plus plus add 1 to its operand. It is going to add 1 to its operand. It is going to add 1 to its operand. While decrement operator is going to decrement. Decrement decrement while the decrement operator minus minus subtract 1. While the decrement operator minus minus subtracts, it is going to subtract 1 and it is going to add 1. Okay, so it can be used either in a prefix or postfix. So we are having a two type, there is pre increment or post increment. So the unusual aspect is that plus plus and minus minus may be used either as prefix operators. It is going to be used either as prefix. So prefix operators means before the variable before the variable before the variable, as in plus plus n, or postfix postfix after the variable that is n plus plus. Okay, so in both the case it is going, means you can use, if you are having some value n, then you can use n equal to 5, then you can use n plus plus also, it is also going to give you 5, plus plus n is also going to give you 5. And even if you sorry, it is going to give you 6. Okay, it is going to give you 6. You can either use in postfix or prefix. Okay, you can either use as a postfix or prefix. So it is going to your 6, it is also going to your 6. Okay, and even same as minus minus n and n minus minus, it is going to give you 4, and it is also going to give you 4. Okay. So now, but what is the difference between these two? But what is the difference between these two? Pre-increment and post-increment. What is the difference? The expression, now we are talking about pre-increment. The expression plus plus n increment, plus plus n increment n before its value is used. Before its before its value is used. Okay. While n plus plus increment, while n plus plus increments n after its value has been after its value has okay. So its point number is 3. So with example I will make it more clear. Is saying that the expression plus plus n increment n before its value is used, it is going to increment, plus n is going to increment n before its value is used. Okay, so before using that it will increment that. Okay, so plus n increment n before its, example if I'll take like x equal to plus n, and let's assume n is equal to 5, n is equal to 5, then here if you will print n is going to be 6, and x is going to your 6. Okay, because the expression plus n increment n before its value is used, so it will first increment it. 5 is going to become 6, so it will become 6, and then it will assign, then it will do. So how this will going to perform plus n, it will going to execute as n equal to n plus 1, then x is going to n, like this it is going to be performed. You can assume that x plus n is like this. And while n plus increment n after its value is going to be used. So if example, if same example, n is equal to 5 and x you are doing n plus plus, so it will execute like x equal to n, then n is going to your n plus 1. X you are going to get 5, so if you print x you are going to get 5, and n if you print, then you are going to get 6. This is the difference. Here both is going to get 6, here one is going to get 5. Okay, this is the thing. Understood? And one more important thing, that we can apply increment and decrement operator only in a variable, not in an expression. Okay, so the increment, it is very important. increment the increment and decrement operator, the increment and decrement operators, increment and decrement operators can be can only be can only be applied to a variable. It is going to be applied only to a variables. Okay, only to a variables. Okay, it can't be applied to a expression, can't be can't be applied to an expression. Okay. Example, I plus j plus is illegal. It is not allowed. It will give you error because it's an expression. I plus j is your expression. It can be only be applied to a variable. Okay. Now next. Now when you don't want the value, okay, in a in a context in a context where no value is wanted. You don't want any value. In a context where no value is wanted, just increment effect. Just you want the increment effect, you don't want the value of that, you just want to, means you don't want to assign that value in any operand. You just want to increment it. If you just want to increment it, then prefix and postfix both act as same. It is going to be both act as a same. So in a in a context where no value is wanted, when no value is wanted, just the increment effect, just the increment effect, just the incrementing effect, just the incrementing effect. Okay, the post fix and prefix are the same. Okay, if you are writing in a code, if you are writing in a code, like if you are doing something, if your n is your 5 and you are doing n plus plus, it is also going to give you n equal to 6, and plus plus n is also going to give you n equal to 6, because here you are not assigning to someone. Okay, you are not going to in a context where no value is wanted, you don't want the value in somewhere else. It will be in both the case, the post and pre, just like if you do, so some people get doubt, sir, in for loop while I equal to 0, I is smaller than n, if I'll do I plus plus like this, then what will be the what is going to difference, and like I equal to 0, I is smaller than n, and I plus plus. See here we are not using the value in the any assignment, so the expression value is going to be I. Here also it will execute as I plus 1, here also it will execute as I plus 1. Okay, so here we I plus 1 is going to increment by 1, here also I getting. So in a context, see, in a context where no value is wanted, you don't want the value in something, just increment effect. So postfix and prefix are the same, then postfix and prefix are the same. Okay, understood. Now we generally use postfix and prefix in some code, like if you want the code, if you are having a code like delete, like, now we are writing a code, delete delete all c from 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 the array, from the array s. You want to delete c from array s. So whenever you will have c, you will delete from s. Means you are having, I am writing void sequence, void is quiz. Okay, and you are having char s and int c. Like this you are having. Now here you are having int I, here you are having int ing. Now you are doing for I equal to j equal to, means both is going to have same. You are assigning I equal to j, j equal to 0. Means I and j is both going to 0. J you are going to 0, I is going to be 0. Now you are checking. See, this is a array of character. You know that. So it will check till it is going to have not equal to null. Okay. So it will increment to 0. So you know that last character is going to your null. So you are scanning one by one and then incrementing. I will teach you all this in the next class, for loop, while loop, all this. So if we are checking, if s of I is not equal to c, if it is not equal to c, then what you are going to do? You are incrementing. You are first. See, this is I. This is I. In the j is going to 0 only. Then increment after. So here how it will work? This, see, my main intention is to clear this one. It will work like this code. If you write this code like this, it will work like if si not equal to c, it will first j is going to become, so j will be as it is. First it is post increment, first assignment will happen sj, then this will happen, then I will get increments, then j will get increment, j equal to j plus j equal to j. Understood? This is the meaning. If you are writing in the suffix j plus plus, so first it will be have j, then it will get increment. Understood? And at last, this is the code. Okay. In this code, I just use this code just to explain you that how this is working. How this is working. Whenever you are writing sj plus plus is opposed to, so first it will be as a j. You will, so at 0 it will, you are going to get I. Then understood? Fine. Anyone having any doubt? Now we are going to see increment and decrement we have seen. Now we are going to see bitwise operator. Now we are going to see bitwise operator. Bitwise operator. Okay. Anyone having any doubt? I think that no one is having doubt. Fine. So please like the session. Please like the session. Okay. So we are just remaining few things. Bitwise operator is remaining. Conditional of assignment. Operator and expression is there. And so we are going to finish our types operator and explain. Just little bit is remaining. Now we are going to start. Madhura is saying on so previous slide. Yeah, it is deleting delete all C from array S. It is deleting C from array S character S. So it is checking if it is equal to C. Okay, if it is equal to, if it is not equal to C, then only in S it is writing I. Writing I. So my main intention is not to explain you this code. My main intention is to explain you this, how this will execute, how this mean, how, what is the meaning of this. Okay. Fine. I think that it is done. Madhura, is it done? Please comment. Fine. Now see bitwise operator. Now see bitwise operator. So C provides six operator for bit manipulation. Okay. So C provides six operator, six operators for bit manipulation. Bit manipulation. Okay. Six. You are having a six. What that six is there, I will tell you now. So this may only be applied to, so this bit operator is going to only be applied to a integral operator, is going to be applied to integral operands. Okay, integral operands, that is char, that is char, sort, in char, sort, int, long, int and long, whether signed or unsigned, both, whether signed or unsigned, you can apply this, signed or unsigned. Okay, so you are having a 6, so this may be applied in integral operand, that is char, sort, int, log, whether it is assigned or unsigned, you can apply. So if you are having like and one way, so what are the 6? And bitwise, or inclusive, or bitwise exclusive, or left shift, right shift, and this is negation, that is unary, one's complement. So it is called as bitwise and, it is called as bitwise and it is called as bitwise, it is called as bitwise inclusive, or it is called as bitwise exclusive, or it is called as left shift, and it is called as right shift, called as, and it is called as once, is called as one's complement, that is it is a unary. You write it. So exclusive or is even called as bitwise bitwise or, okay, is even called as, okay, okay, the bitwise exclusive or is even called as bitwise JOR operator. Sometimes it is even called as bitwise JOR, and bitwise inclusive or it's simply even sometimes called as bitwise or. Sometimes even it is called as bitwise or. Okay, now one by one we will see. Okay, one by one we will see. So first I will start bitwise and, okay, bitwise and. First I will start bitwise and. So bitwise and, first I will start bitwise and. So write this operator, this operator operates on, this operator operates on, sorry, this operator operates on, this operator operates on two operands, on two operands. Okay, it's going to be operands on two operands. While 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 operating upon, while operating upon these two operands, these two operands, these two operands, they are compared, they are compared on a beat by beat analysis. They are going to do by beat analysis, beat by beat basis. So this operator operates on two operand, is going to operate on two operand, and this is going to be perform on beat by beat. The second operand is often called as mask and mask. The second operand is often called as, is often called as, is often called as and mask. It is often called as and. Okay, now if your first, you know this, I hope. So if your first bit, this is your first, the truth table, how truth table will look like? How truth table will look like? If it is having a first bit this, then second bit this, then first bit and second bit, second bit. So if your first bit is 0 0 1 1 and its second bit 0 1 0 1. So 0 0 is going to 0, 0 1 is going to 0, 1 0 is going to. This is the truth table. Now I will take one example. So bitwise and you have seen it is going to operate on bitwise bit. Okay. Now take an example. Example n equal to n and 0 1 7 7. So what it is going to do? So whatever will be the and is and 0 is going to be whatever will be 0. 1 1 3 7 is 3 1, then 7 is 3 1. So last 7 bit is going to be whatever this it is having. Like if you are having n equal to 0 1 6 0 0 0 1 1 0, like this. So what it is going to do? It is going to do 0 0 0. It will have last 7 bit 1 2 3 4 5 6 7. So make it 1 1, like this. So except last means if you want only the last 7 bit of this n, if you want only the last 7 bit of n, what you will do? You can do, this is called as masking. Okay, this is and mask. Okay, mask off, like this they are called. You want only the last 7 bit of this, you and with that, you and with that. Okay, and remaining bit is 0. So how, see, if your n is having 0 1 like this and last 7 bit, so this is going to become 0, and see 1 2 3 4 5 6 7, and this is going to be as it is, because if it is 0 then 0 1 then 1 1 then 1 1 then 1 0 1. Because if you are doing 1 with anything else, See, 1, here is 1. You, if whatever it is there, it will be. Whatever it is there, okay. Because if both is 1, then only. Is it clear? So there we are going to use. So what it is doing in n, we are setting the 7 bit of n to n. So it will be more easy if I'll change to, x. What here we are doing, set set 0 to all, but the, so here we are assigning, here we are assigning the last 7 bit of 7 bit of n into x. This is the use of the bit operator. When you will do a coding, there you can use that. Okay, so bit and we have seen. Now we are going to see bitwise or, that is bitwise inclusive or. Inclusive or, it is easy. Bitwise inclusive or is easy. Okay, now we are going to see bitwise or, that is, so bitwise or, it is even called as bitwise inclusive or. Inclusive or, that is even called as bitwise inclusive. So bitwise or, it is even called as bitwise inclusive or. Okay, so the bitwise or operator is used to turn bit. So where we are going to use that, the bitwise or operator. The bitwise or operator, this is used to turn bit on. Okay, it's used to turn bit on, like x equal to x or set on. So if it is having 1, it is having 1, so always you are going to get 1 because it's or. Okay, it's going to or. So what it is going to do, set to 1 in x, in x. Okay, understood? So its truth table is simple. Its truth table is simple. Okay, no need to see. Okay, let me give draw that one, since I have given for other also. Table is simple only. The first bit, second bit. So first bit inclusive or second bit. 0 0 1 1 0 1. So it is 0 1 1, because other one is 1, you are going to get. Okay. Now bitwise inclusive or is done. Now bitwise exclusive or. Now bitwise exclusive. This is important. Now bitwise exclusive, and bitwise exclusive or, that is even called as, bitwise JOR. That is even called as, bitwise JOR. Notation is, so it produces, it produces output 1 for 1, those input, for 1 those input combination, those input combinations that have, odd number of 1, it will produces output 1, okay, it produces output 1 for 1 those input combination that have odd number of 1s. If it is having odd number of 1, then only you are going to get 1. If it is having a not odd number of 1, then you are not going to get. Produces output 1 for those input combination those have odd number of 1. Okay, otherwise 0. Otherwise 0. Otherwise 0. Okay, so the truth table. So the truth table is like here you are having x, y, and this is x jar. If you are having 0 0 1 1, like 0 1 0 1, it is having odd number, no, so 0, odd number of 1 1, odd number of 1 1, it is having even number 0. This is the truth table. So this is done bitwise exclusive OR. Now we will see left shift and right shift. Now we will see left shift and right shift. Now we will see left shift operator. Now we will see shift operator. Okay. And one thing, don't get confused between bitwise OR and logical OR. Okay, this is different between these two. Okay, this is logical OR and this is bitwise OR. Don't get confused between. Now shift operator. The shift the shift operators, this and this, that is left shift and right shift, performs perform left and perform left and right shift, perform left and right shift of their of their left operand, their left operand, their left operand, whatever is in the left operand, that will produce left operand by the number of by the number by the number of bit position, by the number of bit position, number of bit position given by the given by the given by the right given by the which must be which must be. So what I mean here is very important. The shift operator, that is left shift and right shift, perform left and right shift. So this is going to perform left shift, this is going to perform right shift of their left operand. Whatever will be in the left operand you will give, it is going to perform left shift or right shift by the number of bit position. Whatever number of bit position you are given, by the number of bit position given by the right operand. Okay. In right operand, whatever the number of bit position you have given, that is going to be, which must be positive. So with example, it will be more clear. Take example x left shift 2. It is saying that x is a left operand. You are going to perform on x 2 left shift. 2 left shift. So like if you are having 1. So let me write first. Shift shifts the shifts the value of x shifts the value of x left by 2 position, by 2 positions. By 2 position is going to shift the value of x left. It will shift the values of x by left by 2 position, which by 2 position, filling the vacated with 0, filling the vacated with 0, filling the vacated bit with 0. Okay, so like if you are having, so this is equivalent to this is equivalent to multiply by 4. This is equivalent to multiply or multiplication by 4. This is equivalent to multiplication by 4. Like if you are having x is having 1, so it is, you are doing x left shift 2 only, means this is bitwise 1. So you can write 1 as 0 0 1 bitwise and 0 0 1. Now you are performing this, it will be here 2 left shift, and left is going to be filled by vacated bit is filled by 0. So it is like 1 into 4. So it is bit, if you are doing 2 left shift, it is multiplied by 4. If you will do 1 left shift, it is multiplied by 2. It is multiplied by 2. 2 left shift, it is multiplied by 4. 3 left shift, it is multiplied by 8. 4 left shift, it is multiplied by. So whenever you want to multiply any number x equal to x into 2, no need to do this, because multiplication is the bitwise operator work faster than that this arithmetic. Okay, because it is a bitwise bit, it will working internally only, it is doing. You just do in place of this x equal to x by 2. It will work faster. So in a competitive programming, you use this instead of this. Okay, no, you want to do into 2, so it will be left shift 1, left shift. Let's take an example. With example, it will be more clear. Now take 1, 2, 4, 6. Sorry, 1, 2, 4, 6, 8, 8, 8, 12, 16, 16, 10. So I am taking 4, 1, 0, 0. If I'll do one left shift, it will be 4 into 2 is going to 8. Now x, let's assume x is this. X left shift 1. It will be 1, then 0, 0, 1. Bit vacated. So see, it is 8. Okay. This is the left. Now right shift. Left shift we have seen. Now right shift. Right shift is like divide by 2. Okay, right shift. But it is having some condition. Now right shift. Okay. Right shift. Right shifting. So here it is having different performance in case of, if it is a signed or if it is unsigned, it will perform differently. So right shifting and unsigned, right shifting and an unsigned quantities, right shifting and an unsigned quantity always fills vacated bit, always fills vacated bits with 0. If you are doing right shift to unsigned quantities like 1, 0, you are doing a right shift. You are doing a right shift, so 1 will be here. This vacated will be 0. In case of unsigned quantities, unsigned, because 0 is used. So that's why in gate exam they will do right shift always on the unsigned quantities, because in case of signed quantities it is machine dependent. So right shift on signed quantities will depends on machine. On unsigned quantities it is always going to be filled with 0. On unsigned it is always going to be filled with 0. Okay, it is always going to be filled with 0. But in case of signed, it is machine dependent. Sometimes it will fill with 0, sometimes it will be 1. Okay, right shifting, right shifting a right shifting a signed, right shifting a signed quantities, right shifting a signed quantity will fill with will fill with sign bit, sometimes sign bit, that is sign bit on some machine. Okay, sign bit, sometimes it will fill with sign bit on some machine, and sometimes it will put 0 on some machine and with 0 bits on. Okay, so that's why in gate exam they will never ask you right shifting on the signed quantities, because it's machine dependent, it's going to be machine dependent. Okay, so generally right shifting and unsigned, right shifting right shifting and and unsigned, right shifting and unsigned, right shifting and unsigned uh, quantity, right shifting and unsigned operand or unsigned quantity. So this is right shifting and unsigned quantities for unsigned quantity. So if you are doing right shifting one, it means divide by 2, means divide by 2. Right shifting by 2, it means divide by 4. Right shifting, it means divide by 8. Here means divide by 6. Okay. It is for unsigned quantities, not for signs, because for signed it is machine dependent. Okay. Now we will see the last bitwise operator that is left is our ones complement unary. That is this one is left. This ones complement unary. Okay. So shift we have seen, right shift also we have seen. Now we are going to see. Now we are going to see negation, that is called as ones complement. So you know that ones complement, it is unary. It is a unary operator. See, these sessions may be going long, but it is very useful for your placement gate and for all competitive exam where C is where from means where C is in the syllabus. So I know it sometimes it looks boring, but you are going to learn many things new, many new things in this class. Okay, because I'm going to teach in depth. So people, I don't know why people don't like studying in depth. They want only quick, in fast track only to see the only this some things. Okay, so I don't believe in to go in touching only the part in living. So I want to go in deep. So I teach in a deep in that way only. So I will go in every in detailed way I like to teach. So I will teach in detail only. That's why I'm taking a long classes for every day so that I can cover it in a some less days, like within 10 to 15 days I should able to complete. So you can write the unary operators, the unary operators negation yields yields the yields the ones complement, yields the yields the ones complement and integer, yields and one complement. That is that is it convert that is it convert each one bit into a 0 bit and vice. Understood? So you know the ones complement. So if I give x equal to x and negation 077. Now see, this is a unary operator. Unary operator is having a higher precedence. First it will happen, then this will happen. Okay, this is having a higher precedence. First this operation will happen, then so first negation will happen. So it will be 111, and all bit will be 1, and last 7 bit is going to be last 6 bit is going to be 0. See? Okay, this is going to perform first because it's having a higher precedence. So it sets what it's doing. It sets the last 6 bits of x, last 6 bit of x2 is going to set last 6 bit of x2. Understood? So your bitwise operator is finished. Your bitwise operator is failed. Now we are going to see assignment operator and expression. Now we are going to see assignment operator and assignment operators, assignment operators, and now we are going to see. Is it fine? Anyone is still having any doubt? So write expression such as I equal to I plus 2, in which the variable on the left hand side left hand side is repeated. Left hand side, see here, the variable I is repeated on the left hand side, in which the variable on left hand side is repeated immediately on the right hand side. On the right hand side the right hand side can be retained can be retained in the in the compressed can be written in the compressed form that is I plus equal to 2. So you can write it is equivalent to I equal to I plus 2. So if the variable on the left hand side it is retained, okay, is repeatedly immediately written on the right hand side, this I is written immediately on the right hand side. Okay, so it can be written like this. So the operator plus equal to is called the operator plus equal to is an called an assignment operator called an assignment. Okay. So it can apply with any operators. Okay, so most binary operators has a corresponding assignment operator. So you can use equal to plus 2, you have written into equal to 2 also you can write. So it is equal to I into 2. Okay, understood? So this you can also write. So you can write most. So in place of that, what you can write, most binary operators operators like most binary operators have a corresponding assignment operator. So it is having a corresponding assignment operator. Your assignment operator is this, then assignment plus assignment operator. So most binary operator have have a corresponding assignment operator as a corresponding assignment operator equal to where OP is one of where OP where operator is where OP is one of either it will be plus, minus, multiplication, divide, mod, left shift, right shift, bitwise, and exclusive or inclusive. So you can use all these operators. You can use all these operators. Not only one, you can use all these. Okay. So if expression one expression 1 and expression 2. If expr1 and exp2 are expression, I am saying that it is expressions. Then expression 1 operator is equal to expression 2. If you are writing expression 1 operator, you can have operator, you can have plus, minus, into, divide, mod, left shift, right, like you can have. So if expression 1 operator equal to expression 2 you are having is evaluated, is equivalent, equivalent to expression 1. Okay, expression 1, then expression 1 in bracket, parenthesis is required, then operator, then expression 2 is very important. Don't do mistake here. In gate also this kind of questions is there. Don't do mistake here. You are having a expression, then operator, then equal to, then expression 2, then it will be executed expression 1 equal to expression 1 in parenthesis operator, then expression 2. Okay, so this will perform first. Okay, so let me take an example. With example it will be more clear. If you are having an example, x into, see, I can write here, is your y plus 1. So how you will execute? If you will do x equal to x into y plus 1, then it is going to be wrong, because you are going to do x into y first. Let's take x equal to 3, y equal to 5. Then you will get x 3, 5 plus 1. That is going to, this will perform first because it is having higher precedence. 15 plus 1, it is going to 16, which is wrong. Is wrong. It should be executed as x equal to x into, in bracket, this should be in bracket y plus 1. 3 in bracket, here 5 plus 1, it is going to be 3 into 6, 6 to 8. It is the correct one. Okay, so this is the, this you should know, that expression 1 operator equal to expression 2 should execute like this, should execute like this. Okay, now in gate exam they use one program. So gate previous year, you can say, the same code, they have used the same code that is written in Danish Ritchie book. Same code they have written. Okay, the gate previous year questions, same they have written, same they have written. So there is a function bit count, that count one bits in that count bit. What do they counts the number of ones in this count? But bit count is a function that I'm going to write. It's going to count. Okay, bit counts the count the count the number of ones, count the number of one bits, count the number of one bit in its integer, element. Will bit count. Now I will write the code. In next slide I am writing int. It is the return type, how many number of ones it is having, so that's why it is having int. So bit count is the unsigned x. It is having unsigned, which is having x, so it is going to have int b. Okay, it is having int b. So what this b is going to count, how many one is there. See, I have written here unsigned. Why I have written here I have unsigned, it will be clear. For b equal to 0, x not equal to 0, and here I am dividing by 2, right shift, x is equal to x right shift by 1. What I am doing here, I am doing x is equal to x right shift by 1. I am doing X right shift, doing X right shift, and that value I'm assigning in Excel. That value I'm again assigning. Okay. So these are the code type of code you will get in GATE exam. It is doing X like this, X right shift on one. You are counting. You are counting how many one is there in X. How many one is this? This is very important code. Very important code asked in your GATE also. So bit count is going to count the number of ones in the X. Since is a unsigned, that's why you are doing bitwise right shift, because in unsigned if you will do right shift, the leftmost bit is, means the left bit is going to be filled with 0, going to filled with 0. That's why you are using unsigned. See why I am using unsigned. See here, in right shifting in unsigned quantity always fill the vacated with 0. So the vacated bit is going to be filled with 0. That's why we are using right shift. Okay, sorry, unsigned. So this is gate previous year questions. Okay, unsigned. So you are doing right shift. So before going right shift, so first you will check this will first execute b equal to 0. In initialization happen b equal to 0. Now we'll check whether is it equal to 0. No, if it is not equal to 0, you will check X you have taken. You are doing and with last bit. If this will be true, how? If you are having c 1011 is there. Let's assume X is having 1011. So it will see 1011 and will AND with 001. Now will AND, you will get 0001. It is true, then you will count. So you are counting the number of ones in this X from right side. You have counted one. You have counted. Okay, you have counted. So now after this initialization, this condition check, this initialization happen. This is performed. Okay. So this, sorry, this is happened initialization, then condition check, then you went to the body. Then you are going to do right shift. So right shift, after right shift, you are going to get one right shift. So 101 and left is going to be 0. Okay. Now again X is going to AND with 0001. So initially B was 0. Then because of this it's become 1. Then again you are going to do AND. So it will be 1. 1 condition true. Then 1 will be 2. You will be getting 001. So that's why it's true. Then B plus plus is 2. Again you are going to do right shift. Again you are going to do right shift. So again if you now X is this, now X is this, your X is 0101. Now you are going to do right shift. So it will be, this will get removed 010 and the vacated bit is going to filled with 0 because it's unsigned, because it's unsigned. Now you are going to do AND with X and with, see, after this you will check the condition. Yeah, a not equal to 0, yes. Now you are going to do AND with 1. It's 0. Now this will come 0. So it will not go inside, it will not increment b. Now again it will go here. Okay. So this will happen. Now it will be again do right shift. So now 0 is there. Now 1 will be here. It will come here 1, then rest will be 0. Now rest will be 0. Okay. So now again you are going to do and with this, the condition check. After this again condition check, it is equal to 0. No, it's not equal to 0. So 0 0 0 0, yeah, it's 1. 1. Initially I have given you one. I think that I have given you hmm, yeah, initially X was this 1011. So you have done, you get again 3. So B is now 3. Now it will go there, and now this will go right shift. So you are going to have 0 0. Is it equal to 0? Is it not equal to 0? No, it's equal to. So it will not go inside the body. So see, B is having 3. So it's counted the number of B it is having. After that, it will return B. Is it clear to all of you? How this function is counting number of ones? Number of ones. B is going to your 3. It is counting the number of ones in X. So why we are using unsigned here? because it will filled with 0. So declaring the argument declaring the argument declaring the argument x declaring the argument x to be unsigned to be unsigned in unsigned ensures that when it is right when it is right shifted vacated bit vacated bits will be will be filled with 0. No, not sign win, not sign. Regardless of whatever, regardless regardless of the machine, regardless of the machine, the program. Okay, understood? Now the assignment operator is going to have a value. The assignment, you have seen the assignment operator. The assignment operator is going to have a value. The assignment statement. The assignment statement has a value. The assignment statement the the assignment statement has a value and can occur can occur in expression, and it can occur in expression. Okay, so it is having a value. The leftmost, the this, if you are having like if you will printf percentage d, okay, uh, x equal to 5, x equal to 5, so it will give the 5 plus, you write 5 plus 6, so the output will be your 11. 5 plus 6 is 11. So whatever value it is going to have in the leftmost side, that is going to be the its value of this expression. So assignment is also an expression and can be occur in an expression. Okay, the assignment statement has a value, it is a value and can occur in the expression. So what is going to be the type of such expression? The type and the value. The type of an assignment expression is the type of its left operand. The type of its left operand. So the type of an assignment operator, the type of an assignment expression is the type of its left operand. So the type of the assignment operator is the type of the left operand. Okay, what's the left operand? And the value is the value after the assignment. And value the value is the value after this assignment. After the assignment, see, after the assignment it is going to be your 11, so that's why its value is going to your 11. That's why its value is going to your 11. Okay, and the value is the value after after the the so your assignment operator is done. So I will take one more example and I will explain. Like if you are having uh, c equal to, if you print c equal to, if you have int a equal to 5, b equal to 6, and printf percentage d, you can try in your home in the compiler. C is equal to b into a, so it will be output will be 6 5 is 30, so 30. Okay, 30 is the output, and the type is going to be the type of this is going to be int. Type is int. Why? Because the left side is int, left operand is int. The type of an assignment expression is the type of its left operand. The type of its left operand. Okay, whatever is the left operand is having, and the value is the value after the assignment. After the assignment, what is the value that is going to? So assignment is done. Now we are going to see conditional expression. Conditional expression. Okay. So sometimes we use if and else statement. Now in place, instead of if and else statement, we can use the conditional expression. We can use the conditional expression. Okay. Instead of if and else, we can use the conditional expression. The statement, like this statement, if you are writing if A greater than B, then Z is going to your A. Else Z is going to your B. Okay. Z is going to A or Z is equal to B. If A is greater than B, then Z is either going to A or B. So computes in Z the maximum of A and B. Okay. So the conditional operator written with the ternary operator. This is even called as ternary operator. So it is that is even called as ternary. Is even called as ternary. Okay. Is even called as ternary. So the conditional, right? The conditional expression. The conditional expression retain the conditional expression retain with the retain with the ternary retain with the ternary operator retain with the ternary retain with the ternary operator provides an alternative way provides an provides an alternative provides an alternate way provides an alternate way write this to write this and similar construction to write this if else if else. Okay. So the conditional operation that is like this, that is even called as ternary operator. If you are saying if A greater than B, then Z is equal to A, else Z is equal to B. So the conditional expression written in ternary operator like this provides an alternative way to write this if else statement. So in the expression, its syntax. So syntax is ternary. Here it will be expression one question mark. If it is true, then expression two will execute. Else expression three will execute. Expression 3. If it is true, then expression 2 will be executed, else expression 3 will be executed. So, in the expression, so this is expression only. In the expression, how it will execute? In the expression, the expression 1, the expression 1 is evaluated first, going to your evaluated, going to evaluate. Okay. If it is non-zero, it is, if it is non-zero, means true. If it is non-zero, then expression 2 will get evaluated. If it is non-zero, that is true, then the expression 2, then the expression 2 is evaluated. Then the expression 2 is evaluated, and that is the value of the conditional expression. So if you will print this, if it is true, then expression 2 is the value of this conditional expression. Then is evaluated, and that is the value of the conditional, that is the value of the conditional. Okay. Otherwise, question 3, otherwise expression 3 is evaluated. Otherwise, expression 3 is evaluated, and that is the value. Otherwise, expression 3 is evaluated, and that is the value. So only either expression 2 will evaluate or either expression 3. So only one of expression 2 or expression 3 is going to evaluate. Only one of expression. It is not going to execute both. Only one of expression 2 and expression 3 is evaluated. Okay. So thus you can write Z is equal to, if we'll check whether if A is greater than B, then A is, okay. So you must know that conditional expression is a expression. Okay, it is a ternary operator, or this is a expression. So it can be used wherever any other expression is used. It's a expression. Okay, I am writing here conditional expression. Okay, ternary operator, conditional, it's a expression. So you just write this important note. Don't get confused. Important note. So it is an important note. Okay. It should be the conditional of the conditional, the ternary operator of the conditional, the ternary operator is an expression. Is an expression. The ternary operator is an expression. It is an expression, and it can be used. And it can be used. It can be used wherever. It can be used wherever any other expression, wherever any other expression can go. So it can be used in any expression. Okay. Now if expression 2 and expression 3 are of different type, then the type of the result is determined by the conversional rule that I have shown you, the type conversion. Okay. So if expression 2 and expression 3, if expression 2 and expression 3 are of different type, if it is are of type different types, then the type then the type of the then the type of the result then the type of the result is determined by then the type of the result is determined by the by the conversion by the conversion. Okay, it is going to be defined by the conversion. Example, if f is a float, f is a float, if f is a float, and n is n is an input, then the expression then the expression n greater, you're checking n greater than 0, f and n. So if f is a float and n is an integer, then the whole expression is going to convert it into float. Okay, because the type conversion says that if either of your operand is double, then it will in double, otherwise if float. So here you are having a float. So so the so then the expression this expression then this expression is of type float, is of type float. So if we'll use like I will give with example, it will be more clear. I will take with the example, regardless of whether n is whether n is positive or not. Now let me take an example. Let me take an example. N is your uh, 0. N is your 0. You are checking. You are doing printf. Printf. Okay. You are doing printf. I will take -1. N equal to, I will take n equal to -1. Now if n greater than 0, then if some float and n is your int, it is your int, and float is your f, which is having 10. Okay, 10 point something is there, 0. So what that is going to give the output? -1 is not greater than 0. So you will say, sir, only minus. No. Output will be -1.000060 up to, in it will be convert, it will give the output as a float, because this is a expression and the dominating the is float. So it will convert this into float. The expression, whole expression is going to convert into float. Output will be -1 point, not 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 -1. So this kind of questions they can ask. One options they can give -1, another options they can give -1.66660. So this is going to be the correct. Why? Because it is having the higher. See here. So if f is a float and n is an integer, then the expression n greater than 0, which is going to have, if it is true, then it will give output as f, otherwise n. So f is a float and n is an integer. So regardless of whatever will be the output is of type float, regardless of whatever n, whether n is positive. If n is positive, then also it is going to be float type, because you are having a float in it. Okay, understood? So here parenthesis is not important. Here parenthesis is not important. Here parentheses are not necessary. Why parentheses are not necessary? Around the first expression, around the first expression of conditional a conditional expression, it parenthesis is not important, because it is having a low precedence, only above the assignment operator. Okay, since the since the precedence since the precedence of this is very low, just above assignment, just above. So your conditional operator is done. Now we are going to see precedence and order of evolution. Okay, how it will. You have seen the all the operators. So unary you have seen, type, every operator you have seen. I have taught you all the kind of operator. Now only comma operator is remaining. So comma operator I will teach you now. Then I will go to that. Okay. So I have taught you all the things. Now we are going to see comma operator. Just comma operator is remaining and rest is done. So write comma operator. All operator I have taught you. So that is comma operator. The comma operator, right? The comma operator right in this first point you write a pair of expression. If you are having a pair of, you are using comma operator, okay, you are using a comma operator. A pair of expression, a pair of expressions separated by a pair of expressions separated by a comma, separated by a comma, separated by a comma, is evaluated, is evaluated left to right, is evaluated left to right. If you are having a comma operator and you are using a pair of expressions separated by a comma is evaluated left to right. Going to evaluate left to right, and the type and the value, the type and the and the type and value of the result are type the type and value of the right print. Okay. So what I'm saying here that a pair of expressions separated by a comma is evaluated left to right. It is going to evaluate left then right. Left to right it is going to evaluate it. And the type and the value of the result are the type and operand of the right. The type and the value of the result are the type and the value of the right operand. The type and the value of the right operand. Okay. Going to be example. Example. So here, see in C programming language, comma act as both separator as well as a operator. See, one thing you must write. So comma act in C. So sometimes it acts as a separator, sometimes it acts as a operator. In C programming language, in language, C programming language, comma act as sometimes act as a separator, sometime 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 act as a separator, act as a separator. The C programming language, sometimes act as a the C programming language, sometimes act as a separator. The C programming language, okay, sometimes act as a separator. The C programming language, that is this, sometimes act as a separator, or sometimes the C programming language in C programming language, sometimes act as a separator, and then act as a separator, sometime act as a and sometime act as a operator, sometimes act as a, okay. So C programming language, this sometime act as a separator, sometime act as a separator. So when you are writing int x comma y, then here x here comma act as a separator. Here comma act as a separator. Here comma act as a separator. Not like a not like a operator. Okay. So you write, so the comma that separate that separate that separate functions, that separate function argument, that separate function argument, variable variables in declaration, variables in declarations etc are not comma operator, and do not guarantee do not guarantee left to right evaluation, and do not guarantee left to right evaluation. So the comma that separate function argument, the comma that separate function argument, like variables in declaration that you have seen, variable in declaration is not a comma operator. Declaration are not comma operator. Do not guarantee left to right. It's just a separator. Sometimes comma act as a separator. Sometimes comma act as a operator. So if when it will act, so if you'll write a pair of expressions separated by a comma is evaluated left to right, and the type and the value of the result are the type and the value of the right operand. So it is going to say example, if you write int x equal to 5 comma 6 comma 7 8, and if you print x, the output will be 8. The output will be 8 because the value and the type of the result, the value and the type of the result are the type and the value of the right operand. Okay, so you can try in your home, you will get that. Okay, now we are going to see precedence table. So this is the precedence table. This is our last topic. See, all the operator I have taught you. Okay, not a single thing I missed and I left. Okay, so this is your whatever operator you have seen. This is the precedence table. This is the precedence table. It is having the higher precedence. This bracket. This is in array. This is arrow operator. Okay, this arrow operator, or it is even called as indirect selector, or this is dot operator, or it is even called as direct selector. Okay, so this is arrow operator. When I will teach you structure, there you will get arrow operator, or it is called as indirect indirect selector, called as indirect selector. So when I will teach you array, then you will get the structure, then you will get this. This is dot operator, or it is even called as dot operator, or direct selector. It is called as direct selector. It is called direct selector. Now this unary, you have seen negation, that is not, this is negation, unary negation, plus plus minus, this is unary operator type size. You have seen all this. So its associativity is right to left, and the precedence is means if you are having like like this, and this is having. Okay, so first this will execute, then this will execute. So here I have taught you these things. This is covered. Now star is your strict, like in pointer we use in pointer. Star is used in your pointer. Is used in pointer. It is used in your pointer. So how we use star is your like if you are writing, when I will teach you pointer, it will be more clear. Like int star p is a pointer. Okay, is a pointer. So it reads as means if you assign p equal to ampersand x, so it is read as address of x. So it is even called as, this is even called as address operator. This is even called as address operator. This is even called as address operator, or it is even called as ampersand. Is even called as ampersand. So when I will teach you this pointer, then it will be more clear. Okay, ampersand, and this is address of, means it means address of x, address of operator. It is called as address of operator. So here operand, here operand is x. So here you can write address of operand. You write address of operand. And if you are writing, if p is having something like this, okay. Now if you will write star p, it is used as, it will read as value at that address, value at that address. Which address is this? Value at p, value at that address. So when I will teach you pointer, then these things I will make it clear. Okay, so this is your strict star operator. Strict, you can say it is ampersand. It is called as address of operand, like address of x. What is the address of x? So if you write p equal to, see, if you are writing x is equal to, let's assume x is having an address 100, okay, 100, and it is having a value 5. So p is equal to have address of x. X is this, no? X is this. So p is going to have address of x, which is going to 100. Now this is, if you will print this, it will give value at that address. The output is going to 5. Value at that address 100 is 5. Okay. So these things I will teach you. These are the unary operator. Okay. These are the unary operator. So precedence is your right to left, and and this is your binary operator that you have seen. Multiplication, divide, mod, then plus minus, left shift, right shift. I have covered this also. I have covered all these operator. I have covered all these operator. Okay, so this is highest, this is having highest precedence, then this, then this, then this, like this it is having. And if, and associativity is having right to left for this and for these two. When we, so Rupesh is saying, sir can take marathon session algo and ds please. On algo I will take the marathon session on 16th. On 16th, I am going to take marathon session on algorithm. Whole algorithm I am going to revise. Quick revision course on algorithm. That is going to happen on 1:30 p.m. And it is going to be 12-hour marathon. 12-hour marathon on 16th of 01, 2020. Okay. Topic algorithm. So this you have seen. Now how to remember this? How to remember this? Okay. So all is having a associativity left to right, means if you are having a plus into, if you are having left associativity, means if you are having like plus here into and like b a sorry, a plus b plus c it is having. So first you do this, then you do this. If it is having, no, not, if I will write like this, then it will be, I should write a into b divide c. I have written mod, so I should write it as divide. Okay. See, if you'll see this operator a into multiplication and division, both is having a same principle. Yeah, on YouTube only. On YouTube only. So multiplication and divide is having a same precedence. So please like this session, everyone. Okay, please like this session and share with your friends also. So multiplication and division is having a same precedence. Whenever it is having a same precedence, then it will execute this from according to your associativity. Means which one you have to execute. You seen that multiplication divides both is having same precedence. So go with then associativity. So first you will do A into B. Then after the result, if you will get something as let us assume D, then you will do this D. Okay, so that's the things. When it is having a same precedence, then we will go for associativity. Now, like if you are having there you have seen associativity and precedence and associativity. Now, if you are having A into B, B plus C, so it is having higher precedence. So A into B first performed, then with the result that D plus C is going to. Let's assume this is D. Okay, this is D. This way you have to perform. So this is the precedence table. So this is having you should remember this. So how you should remember? This is U S U. This you can as A. This is shift. This is C. This is bitwise operator. This is L logical. This is logical and logical OR. This is logical and you have seen. This is logical OR you have seen. This is ternary. This is assignment and this is comma operator. Okay. So how you should remember USC black. USC black. This This is parenthesis, third bracket, square bracket, arrow operator, dot operator. Now USC black. U means unary operator, A means arithmetic operator. Arithmetic means multiplication. So within that you know, S means shift, C means comparison operator, smaller than greater than equal, to equal, not equal. B means bitwise operator. So in bitwise operator, this and, not, exclusive, or exclusive, bitwise inclusive, or logical and logical operator. So and will have higher precedence than or, then ternary operator, then assignment, then comma. Understood? So how to remember this? USC black. Okay, in BL AC in between you have T. So U means unary, A means arithmetic, C means shift operator, S means shift operator, C means comparison operator, B means bitwise operator, and L means logical operator, T means ternary, A means assignment, and C means comma. Okay. So to remember, we can write the letter. So to remember this, we write the letter as U as C B L A C. In between, you are going to get T. This you can remember. B L T A C. B L T A C. So U is stands for unary operator, unary operator. A stands for arithmetic operator, arithmetic operator. S stands for shift operator. C stands for comma operator. Sorry, comma not comparison. This C stands for comparison. This C stands for comma. Okay. Comparison. The B stands for bitwise operator. Bitwise operator. L stands for logical operator. Logical operator. Logical and logical or. T stands for ternary operator. Ternary operator. Okay. A stands for assignment operator. A stands for assignment. C stands for comma. Okay. Understood? So like this you can remember the things. What we can write. In this way you can remember. This chart is very important. This chart is very important. One should remember this. This chart is very important. Okay. So all is having left to right associativity. Only unary, unary, ternary, and assignment operator is having right to left. Okay. Understood? Now we will see one more thing is side effect. Okay. We are having one thing in C, that is side effect. Last topic, side effect. Okay. C, like most language, C like most languages, does not specify, does not specify, does not specify the order, does not specify the order in which, the operand, in which the operands of an operator, in which the operands of an operator are evaluated. So C, like most language, does not specify the order. It's not going to specify the order in which the operand of an operator are evaluated. So C, like most language, does not specify the order in which the operand, how the whether operand will first, left operand will be executed or right of an operator are evaluated. Like, so the exception is only, the exceptions are, these are the exceptions, and bitwise and, sorry, logical and logical, or ternary. And so what I mean that with example it will be more clear. See what I mean that if you are having a statement x equal to, you are calling one function and you're calling another function. See, from side effect, in gate they will not ask any questions because it's compiler dependent. Okay. So C, like, C, like most programming, most language, does not specify the order, does not specify the order in which the operand of an operator are evaluated. Means this is an operator, this is an operator, and these two are the operands of this operator. Now C is not specifying that whether this function will call first or this function will call first, whether this is going to be called or this is going to be called first. So this is side effects, side effect. So if both is having some common variable, then the value will be dependent on the order of execution, whether it is a left to right or right to left. Okay, if it is left to right or right to left. See, if maybe, if may be evaluated, if may be evaluated before, G, or vice versa, if may be evaluated before G or vice versa. Thus if either f or G alters a value, if if either f or G alters a variable, alters a variables on which, alters a variables on which the other, on which the other depends, on which the other depends, x can depends on the order of execution, x depends on the order of evolution, order of evolution. Okay. So f may be evaluated before G, f can be evaluated before G or vice versa, or G can be. So thus if either f or G alters a variable, if if either f or G alters a variable which the other depend, which the other depend, x can depend on the, so if it can alter, so both is depending on some value. So thus if a for G alters a variable, if it is going to alters a variable on which the other depend, on which the other function depend, so that's why x depends on the order of evolution. So you will not able to, so it is a compiler dependent, it is a compiler dependence. So this is side effect, this is called a side effect. So similarly the function, similarly the order in which the function are evaluated is not specified. Similarly the order Similarly, the order in which functions functions arguments are evaluated is not specified. Not specified. Not specified. Means whether it will evaluate from left to right or right to left, the order in which the functions argument are evaluated. Argument, whether it will evaluate from left to right or right to left, it is not specified. So example, if you are writing printf, so this is the argument only. Now if we are doing plus plus n, and see this, all these things are compiler dependence, then 2n n. Now you don't know the output, because if this will execute first, then it will increment first, then it will do, okay, if n is your 2, so it will become 3, and then power of 2 to the power 3 will happen. Okay, but if this will perform first, then it will be 2 to the power 2, then it will be 3. Okay, so this is the problem can produce different result. So this example, can produce different result. This can produce different results with with different with compiler different compilers, depending depending on whether n is depending on whether n is incremented whether n is incremented before power is called. Whether it is incremented before power is called. So you write function call is important. So function calls, nested assignment, nested assignment, nested assignment statements, increment and decrement, and increment and decrement, and increment and decrement operators cause side effect, cause side effect, cause side. Okay. So the function call, nested assignment, increment and decrement operator causes side effect. So some variable is changed, some variable is changed, some variable is changed as a byproduct. Some variable is changed as a byproduct of the evaluation of an so some variable is changed. Some variable is changed as a byproduct, as a byproduct of the of the evaluation of an expression. Okay, of the evaluation of an expression. So wherever side effect is there, then it depends upon the order of execution, whether it is executing left to right or right to left. It's depend. So in an expression, in any expression involving side effect, the there can be subtle dependencies, means very delicate dependency, means there can be delicate delicate. Okay, it means very najuk. Okay, delicate dependencies on the order in which variables taking part in the expression are Example, one more you can say, like here is also ambiguity, means side effect, ai I plus. So whether it will use the previous I in the assignment or after increment it will do, it will don't know. So it depends upon the compiler side effect. So the problem here is, the problem here is, whether whether the subscript whether the subscript whether the subscript is the old value, of I, or the new value, the new. That's the problem. Whether it is a new or I. So compiler can interpret in different ways. So different compiler interpret in different ways. So compilers can interpret this in different way. So different compiler will give in different ways and generate different answer, and generate different answer generate generate different answer generate different answer depending generate different answer depending on their on their interpretation. So the standard leaves most of the matters unspecified. So the standard don't say about anything. Okay. So leaves most such matter unspecified. They are not saying anything. So that's why in gate exam they don't ask any questions from side effect. So whenever side effect happens, it's given to the compiler. Whether if you want to, it depends about the architecture. If you want to execute from left to right, you can execute. If you want to execute right to left, you can execute from right to left. Okay. So when side effect, when side effects take place, side effect take place, when side effect take place within an expression, within an expression, side effect take place within an expression is left to the discretion, means nirnay, left to the discretion means nirnay, means it is totally given to the compiler to decide how to execute. Okay. Whenever side effect happen, like in function call or in as a increment decrement, then it will given to the compiler to decide. So it depends upon the architecture. That's why it's machine dependent. Since the based order depends strongly depends strongly on machine architecture, strongly on machine architecture. It depends on machine architecture. Side effects depends on machine architecture. Okay. So whenever any side effect is happening, you will not able to give the answer. Different machine will have different. So your operators and all these things are finished. We have seen all the operators, and in a very detailed way we have seen everything. Okay. Even we have seen the side effect. Okay, we have even seen the side effect where it is a compiler dependence. Like most programming language does not specify the order in which the operand of an operator execute. Like if you are having x and if you are having if function call this, so whether this will call first or this will happen will first, you don't know. So if this is going to be called first, then x value will be different. If this is going to be called first, then x value will be different. So if may be evaluated before g or vice versa. Then if f or g alters a variable on which the other depends, if f1g alters a variable on which other depends, then xn depends upon the execution, order of the execution. Understood? So it depends upon the order of execution. So similarly, we have seen that in we are having side effect on function call nested assignment. Nested assignment we have seen. So this assignment we have seen. Then increment and decrement also we this see increment and decrement. Then also side effect causes side effect. Okay, so this causes side effect. So thanks everyone for watching. So your operator is finished. Okay, and today also we are having a class on Unacademy platform at 7 p.m. There we are solving previous year gate questions of TOC. Previous year, previous year gate questions. So use the code SPSYT to unlock the free plans of Unacademy and to get maximum discount. Maximum discount up to 20%. You can get on Unacademy paid subscription plus subscription. Join the Telegram group given in the description. Like this session and subscribe this channel. Bye everyone. We'll meet at 7 p.m. on Unacademy.